Good afternoon all. Let me discuss about the case study topic on impact of design for testability on yield and reliability in vlsi.
Okay, today we are here to discuss about the design for testability as a case study, which can increase yield and reliability in VLSI. So, in VLSI, we compile millions of circuits to integrate a chip to perform a complex task. While doing complex tasks, it became intricate where we have to test each chip. It is a very difficult task. So there comes a design for testability comes into a play. So what is design for testability? So design for testability is a design procedure where we will check the circuits and chips before getting into the industry. So while integrating this, we will concentrate on two important factors. The chip will work from the initial stage properly, and it will ensure its property for the longer time. So it has four important features where while testing it. First, it's quality assurance, where it should meet the needs of the industrial specification. Second, cost implementation. While using this, we have reduced cost while comparing with field patterns and compliance. So while comparing with the industrial specifications and needs. And the last point is defect detection. It is the most majority and important point where we will detect our problems before the manufacturing. Over to Gagan.
Okay, now when it comes to testing methodologies, there are several testing methodologies. The first one is functional testing. Functional testing means, as it named, it is the testing of function of the IC as it intended or not. It can be performed using various testing vectors which are specified in the design specification. Next, the structural testing. Structural testing involves various methodologies like scan testing and built-in self-test. These techniques are used inside the ICs as it is designed, structure is right or not. The next one is the test pattern generation. Various tools like automatic test pattern generation (AT). The next test methodology is ATCP or test pattern generation. In this method, various automatic test pattern generation tools are used to create a test pattern inside the ICs to increase the fault coverage and while decreasing the test timing. The next one is ICT, internal circuit testing. As it named, it is the IC is placed in the PCB and tested is functionality and connection methodologies. Next one is the boundary testing methodologies. In this method, the IEEE standard of 1149.1 and testing methodology is used on the IC as it interconnection is right or not in the PCB without having direct physical access to the any pins. Next one is the analog and mixed signal testing. This is an advanced testing methodology which involves various advanced implementations like parameter testing and AC and DC test and etc. Thank you.
So let's see the overview of the design for testability. So at first, what is design for testability? As Bhavana said, design for testability is a technique which is used to test the circuit before entering into the test. So why design for testability is important? So design for testability is important for several parameters. At first, enhanced fault detection. By implementing the design for testability, we can improve the fault detection ratio. After that, by implementing the DFT, we can reduce the whole testing time. After that, by implementing the DFT, we can reduce the cost which is used to implement the testing algorithm in the circuit. After that, by implementing the DFT, we can increase the reliability of a particular component, and then by implementing it, we can increase the debugging ratio. So debugging is nothing but we can identify the error and then we can resolve it. It is known as debugging. So let's see the common techniques involved in DFT. So first, DFT is mainly categorized into three types. The first one is ad hoc testing, scan testing, and then built-in self-test. So at first, ad hoc testing. What is ad hoc testing? So ad hoc testing is nothing but it is software testing. It is mainly used for the combination circuits. So in the ad hoc testing, we randomly select a particular point and then test that particular point. By the results of these points, we can tell that the circuit has error or not. by implementing the ad hoc testing, we didn't want any documentation, we didn't want any test case, we didn't want any test subject. After that, scan testing. So scan testing is mainly used for the sequential circuits. So by the name sequential circuits, we know that it has some memory elements. So directly we can tell the scan testing is mainly used for the flip-flops or latches like that. The scan testing is further classified into three types: serial, parallel, and boundary scan. So serial scan testing is used for in the serial scan testing, we arrange the flip-flops and registers serially, and then we test it. In the parallel scan testing, we testing the circuit particularly based on a particular element like latches or flip-flops like that. In the boundary scan method, it is mainly used for the it is mainly used while we place the components on the PCB board. After that, built-in self-test. By the name itself, we can say that it is refers to the circuit which is test itself is known as built-in self-test. In the built-in self-test, we have three main methods. The first one is pseudo shift random generator, and then signal analyzer. After that, DLPLO. So these are the main methods including in the built-in self-test.
The case study is all about discussing about the DFT on yielding and reliability in VLSI. First, I need to clarify about the two terms, that is DFT, design for testability, and yield and reliability. As already all said, DFT is the technique which is used to test each and every part in a PCB, that is going PCB circuits, that the components to be mounted on it. Then yield and reliability. Yield is the term which is used to refer the functionality rate of each circuits. Then reliability. The reliability is the rate which represents the fault in the circuits. Then when we implement this technique in a project, that is mixing signal SOC for consumer electronics, we mainly consider three techniques in DFT. That is to test each and every part of the components involved in this project. The first is that explaining about the scan test. Scan test is all about testing the serial circuits, that is the components which are connected serially, and it is used to test the fault in that circuits. Then next is all about discussing about built-in self-test. From the name itself, we can define that some circuit is already embedded in the integral circuits without any external components. Through this, we can detect the fault in each part of the circuits. Then next is all about boundary scan. Boundary scan is to test the interconnection between the components used in the PCBs. Then it is over to Arvind.
First is default detection rate. By implementing the DFT technique in VLSI designing, we can increases the default detection rate. With studies, it increases from 80 to 95%. Then impact on yield, and the overall yield is from 70 to 85%, which enhances the testing capabilities. It helps to test the chip in early stage of manufacturing. Then impact on reliability. First is fault coverage. By using this fault coverage, we can decreases the post deployment with a percentage of 30. Then impact on BIST, built-in self-test. By implementing the BIST in ICs, it can undergo various conditions to find the defaults in the chip. Then initial cost versus long-term gain. Initially, the cost of the DFT technique is high, but the long-term gain is increases, and it also increases the customer satisfaction, and also it is used to brand reputation. Then conclusion. This conclusion demonstrates the implementation of DFT technique in VLSI designing. It increases the yield and reliability, and also used to find the defaults and fault coverage during the testing process. And also the DFT is highly scalable for different technologies.